Are we filming this?
Yep.
They already got it out of their mirror.
Here we go, 10 points. You know how to turn it
I
on?
was about to say it, and then he already said it.
Alright, so chapter 14 is kind of an overview of the solar system. So we're going to kind of look at our solar system just overall, and then we're going to start studying like each planet. Okay? So, starting with the solar system, first you have the inner planets, also called the rocky planets. Also called the terrestrial planets. Why does it have 3 names? Because some things have 3 names, like I'm Mr. Willis, Tom Willis, and DJ Grandmaster T.
And Pro.
And Pro. So, here they go in order going from the Sun. That's Mercury. That's Venus. That's Earth. And that's Mars. That's how big they are in comparison to one another. Earth is slightly bigger than Venus. So Earth is the biggest terrestrial planet. Mercury is very, very close to the Sun. Mercury is really hot. But Mercury rotates very slowly. And so one side of Mercury is real hot, the side facing the Sun. And the other side of Mercury is real cold, the side away from the Sun. Mercury doesn't have any atmosphere to speak of. Any atmosphere it had got boiled off by the heat and went off into outer space. So it really doesn't have much of an atmosphere at all. The only gases that it has around it are helium that comes up out of the planet for a short time before it goes off into space. It's got a tiny shell of helium around it that's very thin and doesn't last. The hottest planet in the solar system is not Mercury, it's Venus. Venus is further out than Mercury, but it's incredibly hot. And the reason why is it has a real thick atmosphere. Its atmosphere is 90 times as thick as our atmosphere. If you were on Venus, you would feel like you're almost swimming through its atmosphere if you were moving. It's very thick air. And just like when you do your hand back and forth, everybody do their hand back and forth. You can feel the air moving past. It would feel 90 times that thick on Venus. It would be like, you'd be like, ah. But you'd also be really, really hot. How hot would you be? 730 Celsius is the average temperature. That's hot enough to melt lead. Here's a nice little activity you can do. Go home, turn the oven all the way up to broil, wait about 30 minutes until it gets to 550 degrees, and then stick your head in there and feel how it feels. Venus is about twice that hot. Okay?
Did you just put your hand in there? Can you not put your head in there?
Don't even do it. Just take back what I just said about sticking your head in the oven. That's probably not a good idea. But it will give you an idea of how hot it is on Venus. And the reason why it's so hot on Venus is the thick atmosphere traps heat. We call it the greenhouse effect. We have it here on Earth too. We trap just enough heat to keep it at the temperature that it is. If our atmosphere was thicker, it would trap more heat, and we would be a hotter planet. That's what global warming is all about. Whenever we burn something, if you cut down trees and burn them, the trees are no longer there. You know where the trees go? Into the atmosphere as gas, and it makes our atmosphere a little bit thicker, and our atmosphere traps a little more heat. That's called global warming. So we really should probably stop cutting down trees and making our atmosphere thicker and making the planet hotter. It can become what we call a runaway greenhouse effect, which is what happened on Venus. It kept getting hotter and hotter. All the oceans boiled off into the atmosphere and became part of the atmosphere, trapped even more heat, and now it's 700 and something degrees there. We don't want that to happen on our planet. That would be bad. We would not be able to live. Yes?
My mom told me that when she was a kid, people were worried about global cooling.
I don't think people were worried about that. What did she say? Why they're worried about that?
Well, we were just talking about global warming, and she was like, well, like, that stuff kind of comes and goes. Like, people were worried about global cooling when I was a kid.
I don't know. I've never heard that. So, I would want to hear the reason why they were worried about global cooling. We have a good reason to be worried about global warming because we know the temperature keeps going up. As a matter of fact, they started measuring global warming back in the 60s. A guy named Roger Revelle, and your folks probably, and I didn't know about it then because it was just a few scientists studying it. But you could see even back then, temperature was going up, and it still is. It just steadily goes up by 0.1 degrees, a year or even less. And that you can't really feel it from year to year, but over decades and centuries, it can become a bad problem. So we're worried about that. And the solution is to stop cutting down and burning trees and stop burning oil. If we can make all our energy out of solar power and wind and water power and nuclear power even, we wouldn't have to cut down the trees. And so I think that's what the Earth is moving towards, so we can keep from becoming like Venus. That would not be good. Mars is the other side of the spectrum. Mars is a very cold planet. It's further out than the Earth. That's one reason why it's colder. It's also a lot smaller than the Earth. Can you tell how much smaller Mars is compared to the Earth? Look at it. It's about half the size. And that means it doesn't have as much gravity. That means it can't hang on to an atmosphere as easily. And so most of its atmosphere is gone. It has a thin carbon dioxide atmosphere, about 1% as thick as the Earth. And thus it's very, very cold there. The hottest place on the hottest day on Mars is like a cold day in Alaska. I mean, it's cold. But you could still live there. I mean, people live in Alaska on cold days. So we're thinking about going to Mars and colonizing it. And one thing they're thinking about doing is what Jack's studying, terraforming Mars. If we could have big machines there that could make an atmosphere around it, maybe we could make that planet warmer and not be so cold. That's called terraforming. And Jack's going to present his project to you on that at the end of the semester. Now the outer planets, further away, we have our four, we call them the outer planets. We also call them the gas giants. They're much bigger than the terrestrial planets, and they're made mostly of gas. They're made mostly of helium and hydrogen, just like the sun. And this shows how big they are compared to the sun. So that's the sun there, way bigger than the planets. But that's Jupiter, that's Saturn, that's Uranus, or Uranus, if you want to call it that. Uranus is funnier, but Uranus is actually how it's pronounced. And then Neptune. So Jupiter, Saturn, Uranus, and Neptune. Those are the four gas giants, and they're way bigger than the Earth. The Earth would be about as big as that spot there on Neptune. So the terrestrial planets, I think you can fit 4 Earths across Neptune. Neptune and Uranus are about the same size. Saturn's next, and Jupiter's actually, it may be hard to tell by looking at these pictures, but Jupiter is a good bit bigger than Saturn. Now this shows Saturn having a ring, and it does. It has a very pronounced ring. But Jupiter and Uranus and Neptune also have rings. They're just real thin and they're hard to see. So from a distance you wouldn't be able to see them. But when you get up close you can see a little ring.
What exactly is that ring? Is that just atmosphere?
Good question. What are the rings made of? They're made of rock and ice. And what they likely are moons that have been torn apart by the planet's gravity. So each of these 4 planets has moons around it. Neptune and Uranus have like 10 or 12 moons each. and Saturn's got like 30 moons, and Jupiter has like 70 moons. What about the inner planets? Mercury doesn't have any moons. Venus doesn't have any moons. Earth has one moon, the moon. And Mars has 2 moons. They're real tiny though. They're not nearly as big as ours. So what a ring is, imagine a moon orbiting a planet. Now some moons orbit planets and get farther and farther and farther from the planet. And some moons orbit planets perfectly at equilibrium and aren't getting any closer or farther. And some moons are slowly getting closer to the planet as they orbit. And so if a moon is slowly getting closer to the planet, at some point, it's going to get so close to the planet that the gravity of the planet pulls it apart. And it comes apart into pieces. And we're going to study that more when we study moons, but that's what a ring usually is formed by, a moon that has been torn apart. And these pieces are continue to orbit and to fall further and further in, and eventually this whole ring will fall and hit the planet and come apart. Yes?
Is that ring like entirely solid?
It is not. It's made of little pieces. It'd be like if I took a cookie and crumbled it. Then you have all these pieces. And then take the crumbles and just spread them all the way around. Some pieces are bigger, some pieces are smaller. But even like if a piece were real big, it would eventually run into some other piece and break into smaller pieces. So it ends up where most of the pieces end up about the size of like a marble. Or some of them are bigger, maybe the size of a snowball. And a lot of them are small, like the size of sand grains. And they just orbit around and around, and there's a lot of ice there too. Yeah.
You answered my question.
Yeah. So rock and ice, dust, rock and ice make up. It's basically a moon that got torn apart, and it'll eventually fall in. Question.
Do the rings orbit at about the same pace as our moon would orbit? Or?
It depends. Some moons, usually what happens as a moon gets closer because of Newton's laws, it starts going faster. You know what I mean?
Yeah.
So the closer you get to the planet, the faster you go. You can think of water going down a drain or something like that. So the rings are usually will orbit faster than like our moon does because they're so close to the planet. Now, there's some other things you need to know about. Oh, wait, I need to say something else about the gas giants. These planets don't have a surface. You cannot land on Jupiter. You can't land on Saturn. You can't land on Uranus. You can't land on Neptune. You'll go right through them. It's just clouds on the outside. It's clouds of hydrogen and helium and some methane gas. And you go right through those things, all the way down, deep down into the planet, and those gases start getting hotter and hotter the deeper you go, and eventually the gases get so hot that it would melt the spaceship. You'll never reach the surface of these things. Finally, if you get down deep enough into these gas giants, there's a rocky molten core that's kind of like the lava that comes out of volcanoes, but that's real deep down into a gas giant. So we say that the surface of the planet is actually where you can no longer see the gases anymore. And so these gases don't have a surface, these planets don't have a surface you can land on. Yeah.
So are those the gases that we see right now?
You're seeing the gases.
So is the actual planet much smaller than...
Well, it does have a rocky core in the middle, but we don't call that the planet. We call that the core of the planet. And we say the surface is the point where you can see the gas. And if you can no longer see the gas, you're above the surface. See what I'm saying? So these planets don't have a surface that you can land on.
Which planet is like an ocean? It has a big ocean.
That's one of the moons of Jupiter. Jupiter's got a lot of moons orbiting it that are rocky moons that you can land
does
on.
it have again?
Like 70.
Oh.
They're still discovering them. Some of them are so small they're hard to see. 70 or 80 at last count. I don't even know what it was. Every time they publish a book, there's more because they're discovering more. Now, you need to know something else. So you have the terrestrial planets that are close to the Sun. Mercury, Venus, Earth, Mars. And you have the gas giants that are further out. Jupiter, Saturn, Uranus, Neptune. But in between Mars and Jupiter, in between the orbit of Mars and Jupiter, you have a belt called the Asteroid Belt. That's a whole bunch of asteroids right there. And if you were to put all of these asteroids together, you would have a small planet. Maybe about the size of Mars, they think. Maybe a little bigger than that. This is a remnant of a planet that never formed. You see, all the planets formed by a big belt of asteroids that gravitationally came together to form a planet. We call that gravitational accretion, and we'll talk about how the solar system formed. But gravitational accretion is how these planets form. But right there, those asteroids never came together to form a planet, and it's because of the gravity of Jupiter. Every time asteroids start coming together to form a planet, Jupiter, they go by Jupiter, and the gravity of Jupiter rips them back apart. So Jupiter's gravity has kept the asteroids in the asteroid belt from ever forming a planet, and those asteroids are still there. The largest asteroid in the asteroid belt has a name. It's called Ceres. Can you say Ceres?
Ceres.
Ceres.
How do you spell that?
Ceres. And they discovered it back around 1900. And they called it the 9th planet, or the 10th planet. They thought it was a planet. Maybe it was 1800. I can't remember when they discovered it. But they thought it was a planet. I think it was around 1900. And so they thought they had a new planet. And for years it was in the textbooks. So it's a new planet. Another planet, and everybody memorized Ceres. And then they figured out that, you know what? There's not just Ceres here. There's 1,000, 10,000, a million other asteroids here. Ceres is just the biggest one of them. So we're not calling Ceres a planet anymore. We're just going to call it part of the asteroid belt. So Ceres was a planet for a while and then got demoted.
Like Pluto.
Just like Pluto. That's what I was going to get to. So the same thing happened with Pluto. So further out, outside of Neptune, is Pluto. Little Pluto out there, we said was a planet, and for my whole time growing up, Pluto was the furthest planet out, but Pluto is different in a lot of ways than all these other planets, and it has a very elliptical orbit versus an almost round orbit. It orbits off plane. All the planets orbit in a single plane like a record player, but Pluto orbits at an angle, like this. And so, everybody thought Pluto was weird. Well, they found out there's not just Pluto out there. There's like 1 billion other little tiny rocks going out there. And we call that area now is called the Kuiper Belt, where Pluto is, after the guy that discovered it. Just how we have an asteroid belt here, we have a Kuiper Belt here where Pluto is. But it's much wider than Pluto and goes a lot further out. Do you want to hear a cool song with all the planets?
Yeah.
You're all going to love this.
Why he doesn't talk like that one dude? That's terrible.
Alright, here we go. You ready? This will help you memorize the planets.
System from here.
Here we go.
We can see the whole solar system from here. I think we can hear it from here, Joe. We all planets from the solar system.
pass the mic to the planet closest to me.
Mercury is small planet, small as Earth. I get too hot and cold and it's been very slow. On Venus, I got mountains and volcanoes and spray. On the same side as Earth, but in the opposite way.
Yeah, I'm the home to every boy and girl.
Such a beautiful world. I'm Mars, the red planet. I got deserts and ice, and I got 2 moons. That's like 1 moon twice. I'm Jupiter, the biggest planet. I'm a humongous gargantuan. Fast, I'm handsome, grandson.
Please, I'm Saturn. Check out my beautiful rings. Made up of billions of rocks, dust, and other things.
I'm Uranus. I say that with pride. Okay, I lied. I'm embarrassed because I'm the only planet lying on its side.
I'm Neptune, cold, dark, windy, and mysterious. I'm very stormy, so bring an umbrella. I'm serious.
All planets of the solar system. Different sizes for everyone. Music never ends. We are such good friends. And we all orbit the sun.
Well, we are done exploring the solar system. I am thirsty. Let's explore the rest of the Milky Way galaxy.
Is that good?
One more time.
Okay.
Yeah.
One more time?
Oh, yeah.
All right. One more time.
We can see the whole solar system from here. I think we can hear it from here too.
We are planets of the solar system. Different sizes for everyone. Music never ends. We are such good friends. And we all orbit the sun.
We call the sun, rapping work on this track from the beginning. I'm the center of the solar system, planets be spinning around me. So high, I'm moving, you see. Now I pass the mic to the planet closest to me.
Mercury is small planet, small as Earth. I get too hot and cold and it's been very slow. On Venus, I got mountains and volcanoes and spray. On the same side as Earth, but in the opposite way.
Yeah, I'm the home to every boy and girl.
Such a beautiful, beautiful world.
I'm Mars, the red planet. I got deserts and ice, and I got 2 moons. That's like 1 moon twice. I'm Jupiter, the biggest planet. I'm a humongous gargantuan. I spin the fastest, rapid, fastest, plus I'm handsome, grandson.
Please, I'm Saturn. Check out my beautiful rings. Made up of billions of rocks, dust, and other things.
I'm Uranus. I say that with pride. Okay, I lied. I'm embarrassed because I'm the only planet lying on its side.
I'm Neptune, cold, dark, windy, and mysterious. I'm very stormy, so bring an umbrella. I'm
We
serious.
are planets of the solar system. Different sizes for everyone. Music never ends. We are such good friends. And we all orbit the sun.
Well, we are done exploring the solar.
That was fun, wasn't it?
That's a great video.
Something really high.
Told y'all.
How'd you find that?
It's game day.
Internet.
Ooh.
Just got even more about game day.
Say that, are you with me? It's good stuff, isn't it?
Oh my god.
All right.
So much.
Let's take a look at it. Now,
Oh yeah.
there's the 4 inner planets, there's the asteroid belt, and here's Jupiter. You also need to know about the Trojan asteroids. At roughly 60 degrees in front and behind the orbit of Jupiter are a couple of areas that we call Lagrangian points. Can you say Lagrangian points? Lagrangian points are stable areas where anything located in this area, if it starts to venture out of this area, it gets dragged back by the gravity of the sun and the gravity of the planet. It's a weird physics thing that we don't want to get into. It's a mathematical thing.
What is it?
But there's an area, a stable area here that will corral and herd asteroids and keep them in that area. Every planet has a Lagrangian point, has 2 Lagrangian points. Actually, every planet has 5 Lagrangian points. But 2 of them are in front of the orbit and behind the orbit. And there's a bunch of asteroids there too. We call them the Trojan asteroids. Nobody knew about that. Y'all probably didn't know about that. This shows the Lagrangian points. That's Earth. That's the Moon. And here are the Earth's Lagrangian points. L1, L2, L3, way over here on the other side, L4, and L5. And
Those all depend on the sun and Earth's gravity.
it depends on, it's a combination of the Earth's gravity and the sun's gravity. if let's say there's something here, and we've parked satellites there at that point, and they'll stay there. If they start to venture too far this way, they get pulled back. If they start to venture too far that way, they get pulled back. If they start to venture too far that way, they get pulled back. And they actually kind of orbit this point in space, and they go around like this, and they orbit the sun also at the same speed that the Earth orbits. Those Lagrangian points are stable points that things will stay in. And there are some asteroids out there at the Lagrangian points, and we know there's some asteroids on the exact opposite side of the Earth, opposite side of the sun from the Earth, where there are stable and there are asteroids.
What do you mean by stable? Like
Stable, I mean they'll stay there.
They just stay as a clump.
They stay as a clump there. And that clump moves though. That clump moves around the sun at the same speed that Earth moves around the sun. So if it gets too far away from that point, it'll go back to that point. So they stay there forever, as long as the Earth is there.
They're not all touching though, are
They're
they?
not touching.
They're
They're
in this like.
they're in a general area of space, which is actually a pretty big area, and they're just kind of going around and around a point. That's called the Lagrangian point. Isn't that crazy? So some people think, what if there's a big moon there that we can't see because it's on the other side of the sun? There might be another Earth over here on the other side of the sun that we don't even know is there, that orbits at that Lagrange point, and we can't see it because it's on the other side of the sun. Wouldn't that be cool?
Yeah.
There's not one, by the way. They mathematically figured out there's not one.
How?
But for a while, cause I think it would have its own spots here, and they could look there, and there wasn't anything there. I'm not exactly sure how they figured that out, but anyway, this shows the Kuiper Belt. There's the sun, and there's the orbit of Pluto. And there's how big the Kuiper Belt is. The Kuiper Belt is a huge area that contains millions of asteroids. And it's very, very wide, and Pluto is just the biggest one, the first one we saw in that Kuiper Belt. But we now know through mathematics that there's probably about 300 bodies as big as Pluto or bigger in the Kuiper Belt. We just haven't discovered them all yet. We have discovered a few. There's one called Maki, and there's one called Xena, and there's some other ones, and I think it's Maki that is as big, that's bigger than Pluto. We've discovered a body out there bigger than Pluto. But we don't bother teaching everybody this and memorizing all this because we just call it part of the Kuiper Belt. Yeah?
So are they getting closer, or are they just staying like people?
They're not getting closer, they're just orbiting around this area around the sun. And it's a very slow orbit. I mean, Pluto itself takes something like 130 years to go around the sun once. And things that are further out than Pluto are even slower. So it might take these things on the edge thousands of years to go around the sun one time. But that's not even the extent of the asteroids that are out there. Because further out than the Kuiper Belt is another huge area called the Oort cloud. Can you say Oort cloud?
Oort cloud.
The Oort cloud is a bunch of asteroids and comets. And by the way, the Kuiper Belt also has a lot of comets. Do you know what a comet is? A comet is a big ball of ice. So the Kuiper Belt has a lot of asteroids and comets, and so does the Oort cloud. Lots of asteroids and comets that are way further out than the Kuiper Belt. That little blue thing there is the Kuiper Belt. Look how big the Oort cloud is. It's a huge collection of asteroids and comets that's out there that we didn't even realize was there until they started probing with big telescopes And actually, every time a comet comes into the sun and goes around the sun, we can plot where it came from. And they figured out from that there's a whole bunch of them out here, slowly orbiting the sun, taking thousands and thousands of years, maybe millions of years, to go around the sun one time. Carl Sagan wrote a book about these comets. It's called Comet. If you want to read a cool book about space, read Comet. And he talks about what it would be like to be on one of these comets, going way around the sun. The sun would be so far away it just looked like a star. A bright star, but just a star. And it'd be mostly dark and black and cold, and you're on a big ball of ice. And he imagined that that ball of ice runs into another ball of ice. And that slows the ball of ice that he's on down, and it starts falling into the sun. And getting faster and faster and faster. And then it heats up as it gets closer to the sun, and then it whips around the sun gravitationally, and then goes back out. The whole book about it.
How does it not melt off?
It does melt. A lot of it melts off and comes off of the comet as a big tail. Have y'all ever heard of like Halley's Comet? That's one that comes around every 72 years. Yeah.
Are there predictions that there's going to be like a comet falling to Earth at like sometime?
Well, they think that one of these comets gets struck and falls in and actually hits the Earth about once every 60 to 150 million years. They think that's what killed the dinosaurs. A comet that smacked the Earth 65 million years ago. Nowadays we have the technology where we can kind of see these things coming. And we may be able to deflect one if we see that it's going to hit us. Usually what happens is they come in and they go around and they go back out. And then hundreds of years later they come back and go around and come back out. And you can calculate from that, it often will get closer and closer to the Earth until it smacks it. The whole process might take 100,000 years. But as old as the solar system is, that's just a blink in the billions of years the solar system has been around. So if you see one coming around like this, and you figure out its orbit, you can predict, hey, it's going to hit the Earth in 1,000 years, and you could deflect it maybe and keep it from hitting the Earth. There's science fiction books about that too. You could shoot a laser at it. You could run another comet into it. You could hit it with nuclear bombs. You could put a solar panel on it that concentrates light and melts some of the ice, and that gets it shooting off gas and will push it out of the way. There's all sorts of ways you can deflect a comet. Of course, if one gets bumped and it happens to come in, and it's right on track to hit us, we won't have time to deflect it.
Oh my gosh, that could happen.
We'd just be hit. And it could kill everything on the planet.
Wait, so what would happen like if you didn't?
If you didn't deflect it and it hit the planet, you would have a giant impact.
How much time would you have to prepare for that?
It depends if you saw. If it came from the other side of the sun, you might only have a couple of days.
Oh my God. Oh wow.
If it came from this side of the sun, from the dark side of the sun, you could see it coming. But if it came from the other side of the sun, we wouldn't be able to see it with our telescopes because it's during the day. You know, it's on the side of the sun, behind the sun. And then if it whipped around the sun and hit us, it'd be all over.
Would anything live?
Depends how big it is. If it was small, it wouldn't do much. Burn up in the atmosphere before it hit us. If it was giant, kill everything.
The whole world?
Yeah, it could destroy the whole planet. Probably not blow up the planet, but it could cause the planet to get real hot and burn up everything living on the planet. I have a cool video I'll show you when we study asteroids of a giant body hitting the Earth.
Heck yeah.
And what would happen. It's like an 8-minute video showing everything that would happen. It's not good. Yeah.
What if like a comet, like you said, burns before it hit Earth?
If it burns up before it hits Earth, that's just a shooting star. You ever seen one of those?
Yeah.
That's a little tiny thing burning up before it hits the Earth. Now, comets, by definition, are big things. They're like the smallest comet is 1,000 meters. So that wouldn't burn up. That's like 10 football fields wide. That wouldn't burn up before it hit us. That would hit us and cause some problems. I didn't quite get the solar system formation, but we'll do that next time. And on Monday, we're going to set up